Tom Mankey, Friends Community News Group. We are live at the Owosso Filtration plant, and we're with some people here, and we're going to be taking a tour today. I'm going to let them all identify themselves. Let's go from my left around.
Okay. Rob Tice, Mayor of Owosso.
Ryan Suhanik, Director of Public Services and Utilities here for the City of Owosso.
David Hout, and I'm the superintendent here at the plant.
Jerry Haber, Mayor Pro Tem Owosso.
And what I'm here for is I'm going to take a tour with them. This is going to be raw. There's going to be no editing on this. It's just a raw video we're going to be doing and putting it up. So, here we go.
I'd like to start with a little history. 1895, the City of Owosso built the first pumping station with a 275,000 gallon tank. And that addressed some concerns and some growth there. Shortly thereafter, the City of Owosso became the first municipal water system in mid-Michigan. So we're a historic entity in itself. In 1920s, the engineering and design for the underground reservoir, which stores 1.75 million gallons, was put together, and shortly thereafter that was built. It was not used right away. The plant that we're in now was originally constructed in 1935, and it was actually producing water by 1941. So that's the background and history of how this plant became what it is. And we're looking at the last major update, construction update to the plant took place in 2004. So we have a section of the plant that's 2004, 20 years plus, and we have a section of the plant, the rest of the plant starts from 1934, 41, some of the reservoir 1920s, all the way to our day now. So we're pushing 100 years on portions of the rest of the plant. It was a federal project, so that was part of the reason why it was built and then set for a while empty. And it also was during the war years, and things were a little bit different how things started up and how growth took place. So that accounted for the period of time between when they started the engineering work and actually started doing full production from this plant. We're going to kind of go through the plant and the process. We're going to look at the major components. We're going to try to highlight where the water goes to the plant and give information as to what its current status is, the different pieces of equipment, components, what we do, and hopefully that'll help us understand more about the water plant. For instance, we're a groundwater plant. So our processes are aeration, lime softening, solids contact clarification, recarbonation, filtration, chlorination, and fluoridation. And those are the things that we accomplish with the current process. Our groundwater comes from 7 different wells currently. We've recently added one more well to our group. And you might say that's a lot of wells. Do we need that many? Well, our wells altogether today can produce 2,730 gallons per minute. So that's 3.9 million gallons a day. But we don't want to run our wells continuously like that. You want to run them, as an example, you run them for 3 days, you let them set for 3 days. So in effect, we have available to us 7 wells, but we should only be running 3 or 4 at a time, and letting the other wells have the aquifer recover. But that's our wells. 4 of our wells are now on backup generators also. So if we had a major power outage, we can still get water to our plant here. And that's been a long-standing push by the state Eagle to accomplish that, and with our recent upgrades, we were able to do that, where the majority of our wells are powered independently if needed. From the wells, we have raw water mains. So Osborne Lake, north of the plant here, we have a raw water main that comes into the plant and crosses the river. Our other group of wells is located at Hopkins Lake, and that raw water main comes into the plant from the south primarily. And then across the street in Gould Street, we have a well there in the baseball field area, and that comes across the river also. I mention that because some of these raw water mains are over 85 years old, just as old as this plant. And the river crossings are also quite old, well over 50 years. So they're all aging out and will eventually need to be replaced. A lot of work, and something that we really don't see. It's under the ground, under the river. The next thing we'll go to is the aerator, and maybe we should stop it here and walk over there.
Before we go into the other area, there is a quick question I'd like to ask here at the top of this. There's a large concern today in the populace regarding how much fluoride is being put in the water. And I know Owosso has fluoride in as many other municipalities. Can you speak to that issue?
Yeah, we do add a very small amount of fluoride. There is natural fluoride in our wells currently, and our process does not remove that natural fluoride. So we have to add a little bit to bring it up to the level that the state recommends and that the EPA recommends. So yes, we are currently adding fluoride. There have been some recent events on the federal level that will affect regulations in connection with fluorides, and I think we should just wait and see where that goes, and then make a real good decision at that point. So this large aluminum square unit here, located at the rear of the 2004 additional plant, is our aerator, and it removes the hydrogen sulfide levels. It oxidizes iron and manganese. So that's part of our pre-treatment before it goes into the clarifiers. And basically all the water from the well is pumped through that big pipe on the top, and then it flows down through that. And there's blowers on top that pull the air from the bottom, and that's part of the treatment process. That unit is in poor condition. The inside is in very poor condition, and it needs to be replaced. Not with an identical unit, but with two units, so that you can take it out of service and clean it and service it while the other one is running. And it also needs to be located in an area where it's actually serviceable. That front panel on the unit there is actually one huge door that swings open. You can see the hinges on the far side, and it takes 3 to 4 weeks to actually pull all the equipment out of it, clean it, and put it back together. And that's done from a lift to get us up in that location. So it's an expense that needs to happen if we continue to use this plant.
But you said that's kind of antiquated too, right?
The new ones might have some additional features, but the process is still something that is done. There are some units that are large pipes that go up in the air, and the water flows down the pipes. But it just depends on what you spec out and who you buy it from.
So if you went with, let's say eventually we go with a new plant,
Yeah.
you're gonna still need a aerator. I mean, this is on the list to be done. It looks like, what are we looking at here? 2027.
Fiscal year end 2027.
It says improvements. I don't know if that's a replacement or not, but
That's like
that
a
could be done
rehab.
and still be used for a new plant.
It would not be needed for a new plant.
It would not even
could
needed
not-
for a new
It
plant.
could not be used for a new plant.
Could not
There would be another process that would be
Take its
accomplished
place.
through pressure filtration
pressure filtration. Okay.
and also the RO units themselves,
right.
membrane units. So we do annual maintenance on that. We're going to try to get that done this year, and we'll keep it running.
Let's keep it running.
We're going to keep it running and kind of hope that we don't have to invest hundreds of thousands or more into it.
Okay. Okay. All right.
Okay?
Yep. Thank you.
You don't take any water from the river at this time, do you?
No, none from the river. It's all groundwater. And so as a matter of fact, our water is good enough that we could actually just chlorinate it and distribute it to the city of Owosso. But it would be very, very hard. And you would have all kinds of issues in the home plumbing, and every resident, every customer would have to have another treatment system in order to treat that water and soften it if we did provide that water like that. So we're in the clarifier room, and here in the clarifier room we have two clarifiers. Now each of these clarifiers, there's 286,000 gallons of water in each one. And from the aerator, which we just saw earlier, water is piped into the clarifier, and then we also have our line, which is piped into the center of the clarifier. There's a mixer in the clarifier, and that's where the process actually starts, where we're softening the water, we're removing minerals and any other elements that are bonding and falling to the bottom of the clarifier. Then what's at the bottom of the clarifier is pumped out and sent back to the backyard here to our lagoons, and we call that our sludge. But it's spent lime, in essence. It's lime that's been used up because it's chemically already acted and softened the water. These clarifiers, of course, were added to the process back in 2004 because it was no longer legal for us to have outdoor treatment units. We had to bring our treatment units indoors for drinking water in the state of Michigan. So this accomplished that, and these units are at 20 years of their life. They will absolutely have to be replaced within another 5 to 10 years. And that will cost quite a bit of money. But in the meantime, we have to take them down and clean them and inspect them, repair and replace parts that go bad. And literally, we will spend anywhere from 3 to 6 months of time with our operators accomplishing that. Sometimes the parts and materials that have to be replaced, we don't have in stock, and we have to order them from Iowa, where they are manufactured, and wait for that to happen and get them delivered here. So in the meantime, one of our clarifiers is down, and the other one handles the load. So as far as treatment units, there is a redundancy here in the units themselves.
How deep are these tanks?
They're 30 feet down. Just shy of that. We use a 30-foot ladder, 2 of them. They go all the way down, and the top of the ladder comes up to the rail, so we can step over. So that's the depth, and that's why they hold 250,000 gallons of water each.
You were saying that with a new plant, you wouldn't use clarifiers?
No, it's a different process, different equipment. In a new plant, we're talking membrane plant, but we would not be using clarifiers. If we do not switch over to a new plant, again, these would have to be rebuilt or replaced with different equipment, which may change or alter the size and location of this building too. An example that was mentioned was in connection with the cheese plant. Did you
Yeah. So the cheese plant that went into St. John's, Michigan, they looked at Owosso. That's what I understand.
Yep.
And they required so much water. This plant, and Dave can detail it more, this plant can only produce so much water per day. And this plant does not have the capability, nor can we add to it. A new plant is basically, as what I was explained to me, is almost like a modular type plant. So when you put a new plant in, you're going to base it on a certain amount of water per day. And if you ever need to grow that plant, you just buy another modular, and you just basically bring it on in, and you can increase your water flow. So for future, let's say industrial growth, to bring in middle class jobs, we would need a new plant to be able to increase our capability.
So are we at a point right now where it would be very hard for us to bring in certain manufacturing and certain businesses in because we just don't have the water supply?
Absolutely.
Capacity out of this plant, correct?
Which is also which also affects our tax base with new taxes coming in.
Absolutely.
Additionally, if you had more capacity, you could additionally potentially bring on smaller communities as well. And if you were to do that, you would spread that utility cost over more heads to try to keep the price per person lower or keep it down. So help spread the cost is another advantage to potentially having a plant that you could increase your capacity.
But just so that people understand that are watching this, at this time, March of 2025, what we're looking at is with a plant just keeping up with what we have to keep our people safe. Is that correct? So you're not doing all of this right now just for increase down the road, but you're doing this to keep our people safe today.
Right. Basically, my point is, and I'll have Dave come up with the numbers. How many gallons per day can this plant put out?
So in 2024, our maximum production per day was 2.2 million. Our minimum production was 1.1 million. So we're right at 1.5 million per day average for the whole year, and it's up or down depending on the season. So that number is still below our maximum capacity. We have some room to produce a little bit more, but not much at all. When it's springtime or summertime and everyone's using water, we're having a hard time keeping up. And it's almost impossible to keep up when some of our equipment is offline.
Gotcha. Yeah, it's from the cheese factory, probably. Because I didn't prep you on that one, but it was enough that we didn't really have the capacity. And this plant can't grow the way it is, the way it operates, to make that happen.
That's correct. This plant has no expansion capability. To expand this plant would cost as much or more than a membrane plant. And so that's why the engineers have said that it doesn't make sense to do. It makes more sense to build a membrane plant that can expand, also that can treat whatever contaminants come our way.
Yeah.
So So that's a big element that is involved in a decision process too.
You touched on the emerging contaminants, and that's a big one too. So, like for right now, like we can't treat PFAS here, correct?
That's correct.
So, if for whatever reason that popped up in the aquifer, we wouldn't be able to actually treat it. Whereas newer treatment capabilities, new technologies such as RO, they can strip those things out. So, and Alan is left.
It is quite loud in here with all the equipment, so if we can keep our voices up a little bit.
Okay, we are located at the bottom of a lime silo. If you look up, you can see the silo. It's got 2 feed chutes. Right now, one slaker is out of service. The other slaker is in service. Both of these units and this whole system is subject to some major repair right now. And we're still trying to determine to what extent that needs to be. But if we were to keep the process running, this would be replaced with a unit that has 2 silos and a different process, a different type of slaker to feed into the clarifier. So this is the lime that is used chemically in the treatment of the clarifiers to soften our water, capture minerals, and remove those from the drinking water as it goes through the process.
The condition, it's very poor. If I remember correctly, one of these is approximately $250,000 to replace.
$250,000 for just one of these
For this
units.
unit, correct. They're a specialty piece of equipment for softening of water. And then this is our other redundant one, which is taking the brunt of the load right now because of this one being down. But as you can see, we've got holes that are they're high pressure, high heat, and it's blown holes actually right through them.
So you're saying this one is down right now?
Correct. Yep.
So if this one goes down, we're in trouble.
Yep. So we're in the process of cleaning this one out. We're actually having a local fab company come take a look to see if they're able to fab it up and get it functional again for us, because unfortunately $250,000 is not something that we had budget for when this blew out. So we were trying our best to be, good financial stewards of the utility users, and trying our best to get this one continued use out of it and not just scrap it and just replace it with $250,000. If we can put 20,000 into it or so, I'm just throwing a random number out there, just to get it functional and running again. We'll have redundancy, spread the load, because if that one goes down, we lose our softening capabilities.
So we just looked at the slakers and the lime silos, and that's the equipment that converts the lime pellets into a lime slurry, and then it's fed into the process and the clarifiers. Then as it all settles on the bottom, it's the lime at the base of the clarifier is pumped out to the lagoons. So one of the figures that we put together for the Baker Tilly rate study was that in the past 5-6 years, we spent well over $600,000 to have lime removed from those lagoons, and that was at a lower price. And now, currently, we have $900,000 worth of lime stored in those lagoons that will need to be removed.
And there's no way to sell that lime?
There is a beneficial use. Farmers could use lime, but still you have the cost of removing it, hauling it, and spreading it on farmers' fields, and to be licensed to do that. So it's not a simple process. The volume of lime that we have has to go to a farmer or a number of farmers that have thousands of acres
And you
spread
mentioned
it
all
out.
the licensing, and they got to be sealed container trucks, correct?
Yes.
There's a lot of red tape that goes along with it. It's not, you're not just throwing it in the back of a tandem open truck. I mean, it's got to be a sealed container and everything. So there's a lot of red tape that goes with it.
With that information, then the engineers, Fishbeck, when they did their study, they recommended that in order to improve the situation, if we're to keep this plant running, we need to look at building a solids handling building, very similar to the solids handling building that wastewater has for their sludge. Same concept, where all the liquids, or a majority of the liquids, are removed from that, and the bulk quantity is then put into a container and can be hauled away at a lower price. So there's savings involved in that kind of operation, additional operation between here in the clarifier, the lagoons, and where is it going to go after that? How are you going to get it there? Well, that prepares that lime sludge for use in some other application. There are companies nearby here in Michigan that also convert this lime to a dry pellet, and then they sell these dry pellets, lime pellets, in bags to farmers to easily spread. But still, the cost of handling that, delivering that, and the licensing to do that is there.